All right, I'd like you guys to grab out your notes for student handout day 4, constructing triangles. You are also going to need a protractor today, so if you wanted to pause the video and grab those and get those passed out, you're more than welcome to. All right, so when we are constructing triangles, in order for a triangle to be formed, the sum of any two sides must be greater than the length of the third side. So we've got this example here. We've got triangle ABC. It has side lengths of A is 7 centimeters and B is 9 centimeters. So we're actually going to get rid of these lines here. What the triangle inequality theorem tells us is the sum of any two sides of a triangle must be greater than the remaining third side. So if I were to add up 7 plus 9, those are two sides. The sum has to be greater than the length of whatever that third side is. We'll call that C since the other ones were A and B. So when you add up any two sides of a triangle, it must be greater than the remaining side or the third side. So when three lengths meet the triangle inequality theorem, then one unique triangle can be formed. So down to question number 1 right here. We have 3 line segments with measures of 13 units, 7 units, and 5 units. We want to know, will these 3 segments form a triangle? So we've got 13, 7, and 5 units. And we've actually got 3 steps of work to show here. The first thing we're going to do is we want to find the sum of any two sides. So any two sides, let's just do these first 2. So I'm going to add 13 plus 7. So the sum of any two sides, 13 plus 7, gives me 20. Must be greater than the length of the third side. So this 20 must be greater than my remaining side, which is 5. That's a true statement. 20 is greater than 5, so that would form a triangle. But I have to test this out 3 times. So now what I'm going to do is I'm going to add up these two sides. I'm going to add 7 plus 5. And I get 12. And then I have to see, is that 12 greater than my remaining side of 13? So we want to know, is 12 greater than 13? 12 is not greater than 13. That's not a true statement at all. So when it says, does it form a triangle? We would say no. It doesn't satisfy the triangle inequality theorem. And you've got to test it all 3 times. Because if we would have stopped after the first attempt, we would have thought it did form a triangle. But you have to test it with each set of sides that you could add together. So question 2, again, we've got 3 line segments with measures of 4 units, 6 units, and 8 units. And we have to determine, will these segments form a triangle? So I'm going to start by adding the first 2 together. 4 plus 6 gives me 10. And then I have to figure out, is that greater than the third remaining side? Is 10 greater than 8? That's a true statement, so we're good to go there. So next I'm going to go ahead and add 6 plus 8. And 6 plus 8 gives me 14. And I have to decide, is 14 greater than that third remaining side, 4? 14 is greater than 4, so still we're satisfying that triangle inequality theorem. We're good to go. Now I've added the first and the second. I've added the second and the third. Now I have to add the first and the third. So I'm going to add 4 plus 8. And I get 12. And I have to decide if 12 is greater than my third remaining side, which is 6. And 12 is greater than 6. So when it says, does it form a triangle? Our answer is yes. Since it formed a true statement each time, it satisfies that triangle inequality theorem. We could create a triangle from those 3 lengths. All right, so now we're going to practice constructing angles. So we have to use our protractor to construct the angles below. So here you can see we've got the beginnings of our angle, and we have to create a 75-degree angle. So I'm going to grab my protractor, and I'm going to put this center of my protractor over here, right on that vertex that it created for me. I'm going to make sure I line that line up with the black line that I'm working with. And since my arrow is all the way to the right, I'm going to start to the right, and I'm going to count up to 75. So 10, 20, 30, 40, 50, 60, 70, and 75 would be about halfway between 70 and 80. So I'm going to go ahead, and you'll notice I'm going halfway between 70 and 80, and I'm putting a dot right here on my paper. And then I'm going to take my protractor, and I'm going to connect this dot right here with the vertex I had created here. And when you're creating that angle, you should also put that arrow on the end to show that those are going to keep going on forever. So what we've just done is created for ourselves a 75-degree angle. Now this next one, we've got to create a 105-degree angle. This is a nice large or obtuse angle. So I'm going to line the center of my protractor up with that vertex. And I'm going to get that line level. And because my arrow is pointing in this direction, I'm going to start over here and count up to 105 degrees. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 105 would be halfway between 100 and 110. So I'm going to put a dot there. I'm going to connect that point with this point down here. And I just created an obtuse or 105-degree angle. So I'm going to have you guys pause the video here and go ahead and create that third angle, that 29-degree angle for yourselves. All right, so for my 29-degree angle, get everything lined up. I'm going to go past 20. I'm going to go almost to 30, and I'm going to go 1 degree below 30 would be 29. And put a mark there. This is an acute angle. Remember, an acute angle is kind of like a cutie in orange. It's a small angle. This is a small angle, 29 degrees. It's an acute angle. All right, now we're going to start talking about the sum of angles in a triangle. The sum of the three angles in a triangle. So the three angles of a triangle should always add up to 180 degrees. So the sum of the angles in a triangle is 180 degrees. And using this information, we can determine if the conditions lend themselves to creating one triangle, more than one triangle, or if they will not create a triangle at all. All right, so we're going to learn about constructing triangles. Triangle constructions are similar to constructing angles, but they require more steps. So we just practiced creating an angle. Creating triangles is going to take a little bit more work. So we're going to use the steps below to construct our triangles. Step 1 is to start with a beginning point. So if I just want to go down to box number 4 here, I'm going to start with the beginning point. Don't really know where it needs to be. I'm going to kind of center it in the lower half of my paper. There's step 1. Start with that beginning point. And then we're going to use a protractor to draw what's called the primary angle, that beginning angle. We're going to measure the line segment if necessary. We're going to draw the second angle at the end point. And we're going to check out angle measures inside this. And I'm going to go ahead and pause and create a second video here.